Okay guys, one of your assignments for this week is to look up data using a URL through a web service of one of the columns in your Fusion table using Google Refine. That's a pretty tall task and very complex, at least to do it the first time. And so I'm going to give a demonstration. I'd like you to try to do this with one of your data sets with something that makes sense. If you get tied up or get stuck doing that, you can walk through the example that I've provided and turn that in as your unit, maybe for less points. But I'm going to walk through this example, and I'll also give you some text instructions for how to do this. So basically, I have created a Google Fusion table based on US weather stations that I downloaded, and this file will be available to you in your in the class shared folder. So this is all weather stations for the United States. I don't want to have to look up the URL for all of those. That looks, I think it's like 2,000 and some records. So what I'm going to do is filter that, and the way to do that is to go to filter here. Actually, let me back up for a second. You may be used to Fusion tables in the classic look, which we've typically been looking at a table first, and then we go to visualize, map. They've created a new look, which may be more useful to you when you're experimenting and creating different views. So if you switch to the new look, you can create views based on rows or look at your data in a card fashion, so one record per card, or a map, or you can get a filtered view. So this is a filtered table of just Kentucky, and so I can look at just the records that match the state of Kentucky, or I can go to the map here and create also a filter. And so to create a new one of these views, I'm going to remove this view, but to create a new view you can click here and add a map, chart, or row layout. So I'm going to add a map, and in this map nothing comes up at first, and you guys have had that issue before. I'll remove that filter for now. What you have to do is tell it to map based on some geocoded information, an address or location, based on, so this one, instead of the name, I'm going to choose latitude. So again, I went down to map, set location based on latitude, and it's picking up latitude and longitude for that. So then I can zoom in a little bit, see what I'm interested in. Now I can filter to state and just pick out Kentucky, and I can choose just Kentucky if I wanted to. If I want to add a neighboring state, I could add Tennessee to that if I wanted to, but I'm going to take that off and just filter it to the values in Kentucky. So what I want to do in this example is find out how far of a drive it is from Lexington to each of these weather stations. It looks like there's one in Covington, a couple in Louisville, close to Evansville on the border there, and then over in eastern Kentucky there's one. So this station is in Keyfield Airport, and it has a latitude and longitude coordinate for that. So in order to determine how far of a drive and in time and distance it is from Lexington to each of these, what I've done is imported the original data set, which was weather stations in a CSV file. I imported that into a Google Refine project, and so basically I'll give you an overview of the project after I've created it, and then I'll show you how I've created a few of these columns. So basically it was the file US weather stations.csv, and I've changed the name of it. So once I imported it and did a few things to it, I changed the name of it. And again, as you remember, to start a new Google Refine project, you go to open and then create a project, and in this case I went to from this computer, choose the file, and I think I chose this file. It'll be in your folder called usweatherstations.csv. So I imported that file. I'm not going to import another one of those. I can actually get it started. So I imported that file, and it looks like it recognized that it's CSV file, and it looks like it's broken it up into normal columns like I would expect. Then I can create that project. So I'm not going to complete that right now because you know how to do that from your instructions. So then what I've done is I like to see latitude and longitude close to each other. One was over at the end here, and so I went to that column on longitude, and you can edit that column and you can move it to the, I'll move it to the end and show you where it was. It was over here, and I can move it. You can edit the column and move it to the left if you want by one, or you can go in here to the All tab and you can edit columns and reorder them. So I like to drag latitude and longitude close to each other so I can see what I'm doing. The next thing is that let's see, we have latitude and longitude. So then what I did was I looked up using the Google API the distance from Lexington, Kentucky to that weather station. Sounds like a pretty complex task, and what I've done is I've created a little cheat sheet here with some of the values that I used, and I'll post this maybe in progressive parts for you to give you some hints as you're trying to do this. So what I've done is, again, these are based off of the instructions in the Google Refine instructions. So these were documentation for users, and then in this instance I'm following the example or the instructions for extending data calling web services. So I've clicked on that, and basically I've looked at their example there, and they've shown how they've looked up data based on value in one of the cells in one of the columns. So they're looking up information for through web services for 77 Massachusetts Ave, Cambridge, Mass, and they're sending that string to Google API, and it's returning this information. So it's returning the GPS coordinates for latitude, longitude of that address. What we want to do in our example is we want to identify distance from Lexington to the coordinate. We already have the coordinate, so what we're going to do is a reverse lookup, and I've posted some examples there for reverse lookup, and it's based on the Google Maps distance matrix API. So I've posted a URL for that, and in that example they basically show you how to look up the distance. So I'll click the distance matrix API, and you can look at directions or elevation or do other geocoding things. In this instance I care about the distance, so I'm going to scroll down here and see, based on their example, they're showing, and you can't read this on the screen here, but they're showing how to take the API in this form. This is the URL for the API, and then they give it some parameters. And the parameters can be the origin, destination. The origin could be in latitude, longitude coordinates. Destination could be in latitude, longitude, or it could be an address. So in their example here, they've given the origin from a GPS coordinate or a latitude, longitude, and then the destination, Darling Harbor, north, southwest Australia, and then they've given it two addresses. Another one is 24 Sussex Drive, Ottawa, Ontario. So that's general area, and then an address, and then there's other parameters. You can ask it for time and distance if you were driving, walking, bicycling, and you can tell it to return the results in a English or another language if you're interested in that. And then avoid introduces restrictions to the route, so maybe you could say something like avoid bridges or something like that if you wanted to. We won't get into all of that. Avoid tolls or avoid highways. And so there's complete instructions on how to use that API, or at least not complete, but maybe sufficient instructions. So then what we're going to do is we're going to go back to refine here and look at how we did this. So in order to create this column, and if I edit this, I can see that there's information in there on the destination address, so it has determined the address for these coordinates, and the origin address I told it from Lexington, Kentucky, and then it's returning a text with miles, value, duration, that it should take 2.5 hours in driving, and a couple other parameters. So the way that I created that is I went to the latitude and I said edit column, add a column by fetching URLs. So I click that, and then it's basically the default value there is for that expression is value. So that's the value of the cell. So it's saying the value of the new column, which I'm going to call sample distance, is right now it's just set to value. So it's set to the value of the original row, which is latitude of 36.96. So I don't want that. What I'm going to do is copy in my URL parameter here, and I'm just going to paste that in. And now magically for each of those latitude and longitudes, what it's doing is a reverse lookup, and you can actually see some of the results in the preview here. So if you dissect this statement, the first thing that I've added there is the HTTP address for the API and telling it that I'm looking for the distance matrix. It's returning these values in what's called JSON. That's a way of parsing or separating data that it returns. And then I'm telling it in the parameter that the origin is Lexington, Kentucky. If you want to change that, you can say from Louisville, Kentucky. Louisville, Kentucky. Let's change that in this next column. So in my first example, I did Lexington, Kentucky. Now I'm going to find out how far those weather stations are from Louisville, Kentucky. And then what I've done here is I've taken the cells from my table here, cells dot latitude value, so the value of the cell in the latitude column, and I added a comma between those, and then the value of the cells in the longitude column, and then I've told it mode of transportation is driving, and the language is English, and the units I've set to imperial. And sensor is false, so I'm telling it that I'm not using a GPS sensor for that, which maybe I should set to true. So I'm going to click OK, and now it's going to take a good bit of time here to process this request. So it's 4%. I'm going to pause here while that's doing that. Okay, now that it has reported the results, that one is under sample distance. Let's see. Maybe I want to rename that to edit column and rename that to distance Louisville. And so you can see the distance here from Lexington to that one weather station is 2 hours and 35 minutes. In Louisville, it's 1 hour and 57 minutes. Now, is in my example, what I've done here is taken the distance to the weather station from Lexington, and I've split this information out into duration, so it says 2 hours and 35 minutes, and then distance, it's reporting 152 miles, and then I even converted that to a numeric so that I can graph it. So to do that, again, I'm going to post sample code for you to give you a real clear example of how to do this. What you would do is select distance and edit column, and then add a column based on this column. So click. The new one is going to be new column name is going to be distance. Miles. And then what I'm going to do is copy, and I'll again give you this text. I'm going to copy the parser for that, and I'll show you how this works. So I'm going to copy that in. You can just copy and paste this just like I'm doing. And so instead of value, I'm going to paste in, and I'm going to tell I'll read this line and tell you what this means. The value is parsed JSON content, and it's identifying rows, element 0, the category called elements, the array element 0 under that, the distance, and text. And so if you look at this text here, it's parsing down to rows, so it's finding rows, and from within rows it's looking at the array, the 0 or first instance in that array, and then it's finding the elements field, and then it's within that array it's finding the first instance or 0, and then it's identifying the distance and then the text value of the distance, and it's reporting that as the result in this column. So if I took this backwards, I could remove text and it would report text and a value. I could remove distance and it's going to report the earlier portions of that. So basically it's I could just take out and report rows, or you could look down here and find destination address. So I can, instead of looking at rows of that data set, I can look at the destination address, and then it actually did a reverse lookup here and found the address for that GPS coordinate. So what I'm going to do is just paste. Okay, I'm going to go back and copy my text, which you'll have access to, back into this column, and now it's parsing that to identify that it's 113 miles. So I say OK. Voila. So now it's telling me it's 113 miles from Louisville, 152 from Lexington, but you'll notice here in my example here for Lexington, I have 152 mile here. That looks like a text string, right? It looks like text. It doesn't look like a numeric value. You can determine a numeric value by the fact that it's green here. And so what I did to break this out is I just evaluated that first. You read a little bit in your instructions about facets, text facets. So what I'm going to do is create from this column a facet that's a text facet to just basically explore and see what's in that column. So it's telling me, it's looking at all the kinds of text representations that are in there. 100 mile, 131 mile, I'm looking down through here and I see that the pattern is pretty similar, except there's a decimal point, a 0.5 and a 0.0 and a 0.3. So I can't separate that by just well, I probably could separate it by a space to identify the difference between the number and the mile designation here. So let's take that example. So what I'll do is, to try to split this into a numeric value, I'm going to edit cells, Another thing that I'm going to show you really quick that you can do that's helpful is there's an undo redo button, so you can do an undo redo and you can look at all of the steps that you've used to get to the place where you are in this. So if I wanted to, I could undo everything all the way back to that point. I don't want to do that, so I'm going to redo it back up to here. But I noticed that I've used a split element, split 21 cells, miles to station into several columns by separator. So what I'm going to try to do is the same thing here. So I'm going to go up to edit cells, and let's see if this will work. Edit cells and split multi-valued cells. So split, and that's looking for a comma. Well, let's take that comma out and let's say we can split it by a space. So I split it here. Now it went distance, and it actually it didn't retain the mile designation there, but I think that gave me what I wanted. So now it looks like it's just distance, so I can let's look at that again with a text facet, and the text facet basically lets you explore I don't know, facets of that or groups. This thing will do a cluster analysis, so if there's a word that's used similarly multiple times, it will show you that. But it looks like, if I scroll down through here and look at the data, it looks like it's all good numeric data, but it's still black, it's not green, indicating it's numeric. So I'm going to go back to edit cells, and they've got some things that you've read about here, common transformation. So I can go into common transformation. Looks like somebody's already set up one to transform it to a number. Click. Okay, now it's a number. So now I can compare the distance from weather stations to Louisville and the distance to Lexington if I wanted to. So that's all for this portion. What I've basically shown you how to do is use a URL to do a reverse geocode lookup, so identify the address based on the coordinates, and then return a value of a distance, and then clean that up from a text value to a numeric value. This is probably enough talking, and I'll try to add some text to describe this also as the example for this assignment.